The Excel file I had uploaded in the Google Classroom. Please open that. Okay. So, like I said, it is not that I'm like teaching you something new. T-test, cross tabulation, regression, ANOVA has been covered already or will be covered in QT. But my aim is not to like go through the data analysis part, that anyhow will be repeated. My only objective is to, if I give you a question, if I give you a research objective or a project objective, if I give you data, are you able to understand what kind of data analysis you are going to carry out, right? By looking into data, by observing the data, right? And this is what like all of your section B3 questions will be in the same format. For each question, I'll give you a research objective, I'll give you some data, but I'll not mention that what kind of test you have to conduct. That is something logically you have to arrive in the conclusion. And QT and other topics, they'll give you, okay, run a regression or run a cross tabulation or run a t-test. But in my case, because I'm much more interested, you understand whether what kind of data analysis method will be utilized. So these questions will be, again, it is not that similar questions will come, but the framework will remain same. You will have a research objective, you will have data points. So you have to follow this step. First 2 marks is for writing down alternate and null hypothesis. All the 3 questions will have same. You have to write down the alternate and null hypothesis. If you are able to write down correctly, 2 marks is given, right? So in this particular case, if I want to find out research objective is to understand whether a higher education fees is greater than 361,975. This is the same like kind of, if you remember in 2 classes back, I showed you one newspaper article from me where that HSBC had conducted that study, right? So let's say I'm taking that as my base article and trying to prove that whether it is correct or not, right? Find whether average tuition fees is greater than 361,975. What will be my alternate hypothesis?
It will be greater than 361,975.
Okay. And what will be my null hypothesis?
Sir, equal to 361,975.
Equal to or anything else? So alternate hypothesis is correct. It is greater than. Then what about null hypothesis?
Equal to or less than. Equal
Yes.
to or less than.
Less than equal to.
Correct. So always remember exactly opposite of that, right? Opposite of this statement is not equal to, right? Opposite of this statement, if I say my alternate hypothesis is greater than something, right? Opposite statement will be less than equal to, right? So don't only put less than or don't only put equal to. Both the symbol has to be there, right? So then only it makes a proper alternate hypothesis, null hypothesis. Anyone having any questions on this?
Yes, sir. I have a doubt, sir. What to write, sir? In the 2-mark question you told that voice is not clear at that time.
So for each of the questions, all the 3 questions numericals are asked, please write down alternate and null hypothesis. So this statement, alternate and null hypothesis, you have to write. So that will be 2 marks.
Okay.
So,
Now next,
Sir, if the company claims that in a 500-gram bottle they are selling the quantity that they are giving is 450 ml. This is what the company is claiming, but I am saying that but I believe that it's less than 450. So my alternative hypothesis will be less than 450.
correct.
And like you mentioned that the null hypothesis has to be greater than equal to.
Correct.
But so the company isn't claiming, right, that it is greater than 450. It is just saying that it's 450. So
Yeah,
why
even
should we take?
Even it is 450, his company is telling 450, right?
Yes, but sir, it's not saying more than 450, right?
So company is telling exactly 450.
Yes, sir. Yes, sir.
Then it is a two-tailed test. You will prove that it is not equal to 450.
Okay, sir.
So you'll say that it is. You will prove that it is not equal to 450. You are not interested whether it is greater or less. You will prove that it is not equal to 450. That is a two-tailed test.
Sir, in that scenario, our the null hypothesis will be equal to 450 and the alternative will be not equal to 450, right?
Yes. Yes. So you have to look for whom you are conducting that research. If you say I'm conducting for myself, I want to disprove the company. Company is telling it is equal to 450. I want to say no, it is not equal to 450. So my research objective, my alternative story or theory will be it is not equal to 450. Then opposite of that equal to 450 will be the null hypothesis. Then you go ahead and carry out a total t-test.
Okay.
So for each of the question in your exam, you have to go step by step. First, write down alternate null hypothesis, because I think all of you know that you cannot convert Excel file or upload Excel file in Moodle. Everything what you are doing here has to be written. Obviously, analysis part you can use Excel, but the results and these all the statement you have to write in a plain paper, scan it and upload it. Right. So what is my study aim here? What I want to find out?
At the average tuition fees.
Average tuition fees is greater than certain expected value.
Yes, sir.
Right. That expected value I have found out from secondary research is 361975. Right. But my study aim, I have a value 361975. I have to compare with that value and find out that what is my, whether it is greater than less than, that will find out. Right. What are my variables?
Sir, in which class the child is studying?
Is the information given to you? Which class the child is studying?
No, sir.
So for the given data set, it is not that I'll give you a question and you will go to the field. So that is a project. So you'll, but I'm just asking about the when you are like conducting or carrying out in your exam. What are the information given to you?
So only tuition fees.
Yeah,
Tuition fees. What else? Anything else given to you? Any other information, any other variable information given to you?
So it is for higher education. So.
Correct, but that information I have not given. Like Abhijit was telling, higher education, but that information I have not given to you. But if I say that, okay, this is your project, go and find out, you might collect the information on, you can say that, okay, my higher education is another variable, what kind of degree, right? And you will say, for past few students, what I have collected data, those students or those children who are carrying out MBA, then few students were from MCA, then few students were from the MTech, right? So you can collect these data also, right? So each of these number which shows, like you went to one student and asked how much amount of money that he is spending. He says this much. What is the degree he is pursuing? He says MBA. Like that, you have collected some student who are pursuing MBA, how much they are spending. Some student who are pursuing MCA, how much they are spending. Some student who are pursuing MTech, right? But this is when you conduct a actual research in the field, right? You can collect their gender also, you can collect their income group of their parents also, depending upon your research objective. But in this particular case, we do not have in this information, right? Though it is mentioned here, higher education, that variable information is not given. Neither it is required for our objective. If you see, nowhere it is saying that, okay, compare between different higher education or find a relationship. Only it is saying the amount of money you spend in higher education, is it greater than some number, right? Irrespective of higher education. So the information about higher education is not provided to you, right? So that cannot be a variable here, right? If that information is given, like I was showing you, MBA, MTech, MCA, then research objective will be different. Whether there is a difference in higher education fees across different degrees. Am I going to find the difference between the amount of money people spend in MBA, MTech, and MCA? Is there a difference? If I had given that additional information about what kind of degree they are pursuing, in this particular case, that information is not given, right? So this is the only one variable. I have only one variable which information has been given to me, right? In this question, what is my dependent variable? What is my independent variable?
So dependent will be the criteria that's given. So average tuition fees.
Okay, what will be independent?
I think so. Independent variable will be the tuition fees, and the dependent variable will be the higher education.
Yes, sir, yes, sir, yeah. So dependent will be which you have to find out, sir. That will depend on the information given, that is 36197.
Yeah, but no here. So that's what I was telling you, right? You have only one variable. Where the case of dependent independent will come only when you have two or more variables. So if I say something, there is a relationship or dependency or there is a difference, I need to have two variables. Do we have two variables? I have only a single variable, average tuition fees. So that's what I was mentioning, right? Higher education information is not given to me.
Oh yes, sir. Yes, sir.
Irrespective of higher education, I have only information about tuition fees. I have only single variable, right? So dependent. So there is no kind of information about which is dependent, independent, right? So here in this particular case, you'll write not applicable, because the scenario of if I say something is dependent on something else, I should have information about that, right? Tuition fees is dependent on what kind of degree. I do not have information about degree here in this particular question. So this is a univariate analysis. Univariate means single variable. Uni means one. So in this particular case, I do not have the option of multiple variables. I have only one variable, univariate. I have to conduct the test accordingly, right? Then now the data analysis method, right? Again, there are a lot of different, even the non-parametric, when you have categorical data, there are different non-parametric methods, but we are only focusing on the parametric when you have this kind of continuous data. Now the question is, in this particular scenario, when I am to compare with certain number, right? I have two different tests, t-test and z-test, right? When to use t-test, when to use z-test. So when to use, so in this particular case, actually we can use a t-test or a z-test. Shall I use a t-test or a z-test? How to decide on that?
Sir, I guess t-test is for small number of sample cells, like less than 40, and z-test is for more than 30. Yeah, not 40.
Okay.
30.
What else? Is this the only condition or anything else is there? Is this the only condition where I can decide whether t-test or z-test, or any other condition is there, additional condition?
I guess this is the only.
Anyone else having any other answer? So z-test is when your population variance is known, right? So when you have the information about, apart from if it is a large sample size and population variance is known, you can go for a z-test, right? But 99% of the times when you are conducting this kind of study, right, you will not have any information about the population. Maximum information you can have what is the size of the population. If I'm conducting this study for higher education, those students who are pursuing higher education, I'll have approximate idea, okay, 5 crores or 10 crores people are pursuing their higher education, or 50 lakh students are pursuing their higher education, right? That is the only information. I'll not have idea about the variance on their, how much they're spending or the average. If I had that information, I'll not go conduct any like sample collection, right? I have already all the information available, right? So whenever you have the knowledge of the population variance, like I said, 99% of the cases will not have the knowledge about that, right? So go for the t-test. Only when population variance is known, go for the z-test. So when I say sample size less than 30, use t-test, that doesn't mean that if let's say sample size is 100, you cannot use that. Because after above 30 sample size, t-test and z-test, the table, there is not much difference, almost equivalent, right? So t-test is the ideal choice for any kind of sample size. Z-test is when you have the information about the population, some information, population variance, right? Like for in this particular case, what I'm going to study? I'm going to study average amount of tuition fees on an annual basis, how much parents spend in their children's higher education. So for me, the population is those 50 lakh students, right? 50 lakh or 25 or 30 lakh students who are pursuing their higher education within India, right? For them, finding out their all of their how much they're spending and then finding out variance, I do not have that information, right? So I'll go always with a t-test. So most of the times follow t-test, irrespective of sample size, t-test will give you a better answer unless you know the population variance, right? Any questions, any doubt on this? So now the question is what kind of t-test? Under t-test, there are three different types: right-tailed, left-tailed, and not equal, that is two-tailed test, right? In this particular case, what kind of test? Right or left or two-tailed test?
Right.
Right tail.
Right-tailed t-test. Okay. So for your exam point of view, if you're able to complete this part correctly, writing down alternate null hypothesis and writing down these four steps. What is my study aim? What are my variables? What is dependent? What is independent? Data analysis method. This information you are able to write correctly in your exam paper. Out of 10, you will get 50%, 5 marks without doing any data analysis. Data analysis I'm not that much concerned about, that anyhow you can learn, and anyhow I will teach, you are learning it in QT, that will take 5 marks. I am much more interested, given a data set, given an objective, you are able to find out what kind of test. Right now it looks easy. When we cover all those 5 and 6, then only the confusion will start. Finding out variables, finding out which is dependent, which is independent, what kind of test. Because in the exam, I'll not be going to give you, okay, this table is there, follow one sample test. I'll give you all the information, all the data set. You have to find out particular for the question, what kind of data analysis you have to carry out. So for that, you have to practice along with me. So anyhow, I'll be sharing the Excel files, but unless you do it on your own, step by step, you understand, right? You're not able to do it, and one person does a mistake, all of you will copy, and all of us will get less marks, right? So at least try to practice along with me so that you are clear that, okay, I am at least pretty confident that this part I'll be able to complete. Data analysis, anyhow, that you are like come to know like as and when you carry out that kind of test, right? Any question, anyone having any questions on this part? We have not conducted any data analysis, only we have found out what kind of data analysis will be conducted, right? So for this, you can always refer the table, right? If anytime a doubt, okay, how many variables? Univariate. Univariate means t-test. Out of t-test, whenever there is a greater than symbol in right tail, sorry, in alternate hypothesis, that is a right tail. When less than symbol in a alternate hypothesis, that is left tail test. When there is a not equal to symbol, that is a two-tailed test, right? So this part, you can always refer the document. Again, you need not have to refer the document. Once you practice, that should be clear to you. Any questions? Yes, Abhijit.
Sir, is it okay if I ask you something about multicollinearity now?
No.
Okay.
You will ask when regression, we discuss regression.
Okay.
Any doubt on this one sample t-test? Okay. So now how to conduct, I hope all of you know that, but let us try to understand why we are calculating those information, right? Yes, Abhijit.
In the exam, shall we given the tuition fees like this row? And now we have to find this by making in the Excel sheet also. Tuition fees and these values we have to find out, or all these values are given in the table.
Which values?
So the tuition values, as it is written in Excel, in the examination, in same format question will come, na?
Yeah, it will be on the paper. It will not be in Excel. It will be in the whatever Moodle question. It will be there. It will be written there.
Okay. Thank you.
So test statistics, like we discussed in the previous class, is nothing but observed value minus expected value divided by your standard error, right? So before calculating, let's try to understand why we are calculating this test statistics, right? If you remember or recall what we discussed in the earlier classes, test statistics is nothing but a standardized value. Whatever sample data we are collecting, this information what I'm collecting, if I put into a standardized form, right, then that is nothing but a test statistics. Then the question is, why are you standardizing that value, right? Sampling distribution for each of your question nobody is going to create for you. So they have created this sampling distribution, which is a t distribution, which will be useful in a one sample t test or a two sample t test. That has been created by statisticians for any kind of continuous data. So that doesn't mean that they are going to create for each time you conduct a t test. Now the question is for us to use this data, because this data what they've used, they have standardized any kind of continuous data. So this is a standardized t distribution or standardized normal distribution, right? So the definition of standardization is subtract by mean divided by standard deviation. If I take a number, subtract mean divided by standard deviation, then I'm standardizing the data, right? So this table, whatever they have constructed, the statisticians, that is using a standardized data, right? And if I'm going to use that table, I have also to convert my data information to standardized form, right? So when I'm calculating this test statistics, I'm doing nothing else. I'm standardizing my data. So this observed value is nothing but the data information I'm collect from my sample, right? Minus the mean value. If I believe my null hypothesis to be true, this is the mean value 361975. That I subtract divided by my standard error. Then the question is, why standard error, not standard deviation? Standard deviation of a sampling distribution is nothing but a standard error, right? Because remember, we do not have information about the population. We do not have information about the population standard deviation, population variance. We have information about this t distribution. From this, we are trying to find out where does our sample lie, right? And that is why rather than standard deviation, we are dividing by standard error, right? But overall formula, if you see, it is nothing but x minus mu divided by standard error, sigma by root 10 or s by root 10. That is nothing but standardizing the data. Now what happens? I have a standardized t table or a standardized normal table, z table. By changing this value to test statistics, I am trying to find out in the standardized table, in the standardized distribution, where does this sample data lie, right? Then obviously I'll try to find out whether it is in line with the null hypothesis or against the null hypothesis. That is the steps of any kind of hypothesis testing. So first you standardize your data, that is nothing but calculation of test statistics, then find out your critical value, then compare, right? So I'll come and discuss what is critical value, but before that let us calculate test statistics. What is my observed value? Observed value is nothing but what I am observing from my sample, right? So that is the average value what I get from my sample, right? So this is the observed data. Then what is the value I am expecting? What is the value is given in my research objective? That is 361975.
Acha.
Now I have to find out standard error. Formula of standard error is sample standard deviation divided by square root of sample size, right? So then first I have to find out sample standard deviation, right? So either you can go do it manually, find out mean, then subtract from each data, or you can use formula. So if you write STD, there are two formulas, STDV dot P, that is for standard deviation for population. Use the other formula, which is standard deviation per sample, because I'm calculating for this sample, right? So this is my sample standard deviation. So the formula is STD EV standard deviation dot S, that is for sample, all the data points I have taken, right? Then my standard error will become my sample standard deviation divided by square root of Then what is my sample size, right? If you see in the question, it is not given what is my sample size. Then you count how many data points you have, right? If I count this data, I have 29 data points. If you look into your Excel and just drag to the end, I have count is 29. So I have 29 data points. So that time you don't say, sir, you have not given sample size. This is the data point. This is the information which is with you, right? Yes, Abhijit.
Sir, how to find the standard error? I am able to get that.
The formula sample standard deviation divided by square root of sample size. You are asking how to find it or why to find it?
Sir, how to find in Excel? Sir, I was doing the previous one and that's unable to see that.
Yeah, calculate sample standard deviation. Formula is standard stdeb dot s of the sample divided by square root of sample size. Sample is 29.
No, sir, I was asking standard error, not standard deviation.
Yes, so the formula is written here, right? Sample standard deviation divided by square root of sample size. So if you calculate standard deviation, you divide it by square root of sample size. That will give you the standard error.
Okay, sir.
So this is the formula. Sample standard deviation I calculated divided by square root of 29. So the question is, where did I get this 29? I have 29 data points. So that is my sample size. The number of data points I have been given. Clear or any doubt?
Yes, sir, clear.
Now I'll go and find out my test statistics, right? Test statistics is nothing but my observed value minus expected value divided by standard error. Minus 2.94. So this is the first step. So what I did exactly, whatever sample average I got, right? So that is 2,99,470 rupees 40 paise, right? I just change it to a standardized data. I subtracted from the mean divided by the standard error. This gives me standardized data, right? Then now the next is critical value. So now what is the meaning of critical value, right? So critical value is something which provides a boundary for your null hypothesis. If I believe any hypothesis test we start with the initial assumption that null hypothesis is true. So what is my null hypothesis? Average tuition fees is less than equal to 361,975, right? So less than equal to 361,975, right? Remember the terminology what is in my null hypothesis. So if I believe that to be true, my critical value provides a limit to that. Any number, any sample that I collect, if I standardize the data, if I standardize that sample data, that should fall below the critical value because my null hypothesis is less than equal to some value. If I'm getting a sample data, and I believe that null hypothesis is true, then my data point, my sample data also should be standardized sample data, should be also less than that critical value, right? If it is not, yes, Abhijit.
So I have seen that whenever we try to divide the size of a sample, we divide by n-1. So shouldn't we divide here by 28?
Where?
So here to find the standard error, we are dividing the sample
No,
standard
so
deviation by
that formula is for sample standard deviation. So rather than doing manually, I have already used the formula. But if I do it manual calculation, I found out x bar, then x minus x bar, square of that, then sum it up, divided by n-1, that will give me the sample standard deviation.
Yes, sir. Yes, sir. That I got. But for standard error also, shouldn't we divide by
No,
28?
no. Who told you that? Standard error, it will be always sample size.
Okay.
Yes,
Sir,
any other
sir,
questions here?
the standard error is coming different from yours.
Check your formula, what formula you have used.
So it is coming 3,950.8739.
check the formula. What is your standard deviation is coming?
The standard deviation is 114575.3439.
Okay, so that is correct. So you have divided by square root of 29 or what?
Yes, sir. Square root of 29. Sorry. I have something wrong, mistake. Yes, sir, I got it.
So now critical value, like I said, it provides the boundary to your correctness of your null hypothesis. When I am doing a right tail test, if I'm telling my null hypothesis is true, so that means this should be less than equal to some number, right? As long as I'm getting my sample data less than equal to that number, I cannot reject null hypothesis. Once I get a number beyond the critical value, when I say beyond, greater than critical value, then I'll be rejecting my null hypothesis. So that's why I have to first find out what is my critical value. To finding out critical value, I need two information: degrees of freedom and alpha. Right? Degrees of freedom, depending upon what kind of hypothesis testing you are doing, it will change. In our case, we are doing a very like one sample t-test. The formula is simple: sample size minus one. Alpha is 0.5 percentage. It is given here, right? Let's say in your exam it is not given. Still, you can consider as 5%, right? So that is the normal value what we take. So what will be my degrees of freedom? 29 minus 1, 28. Alpha is 0.05, right? So critical value, you need not have to calculate anything. Just go to the distribution. Only thing is that you have to know which distribution you have to go. In your exam, all the information will be given. So when you know that it is a sample t-test, right? Or a two sample t-test, go for a t distribution. If it is ANOVA or regression, go for a F distribution. If it is a cross tabulation, go for a chi-square distribution, right? So that part you have to practice, right? Obviously, there are only three distributions which will be helpful for you. Then those are the only three things what you have to consider, right? Now what happens? I'll go and find out at 28 degrees of freedom, right? And 0.05, 0.05 is my alpha, right? Which is given. Then my degrees of freedom is 28. I get a value of 1.701. So that becomes my critical value, right? So these are the only two information what you need for carrying out your hypothesis testing. So how to use this now? Obviously, you need not have to draw anything, but I wanted to show you visually. Like I said, critical value puts a boundary of your null hypothesis, right? So if I show this value in this visualization, right? So let me draw a line. So this is my critical value, right? So what my, if my this right tail test, if my null hypothesis is true, what it says, it is less than equal to 36197. Any value I get, any sample that I take, if I get the standardized value which is less than 1.701, right? Then null hypothesis cannot be rejected because it is within the range. But if I'm getting a sample data which is above this, which is beyond this number, then null hypothesis can be rejected. So where does this number will fall? I have calculated my test statistics, that is the standardized sample data. Where does this number will fall?
Right side.
Right or left?
Left, sir. Left.
So minus 2.94, right? So what happens here? If I have got this value as 1.8 or 1.9, it would have been in the right side. That is beyond the boundary. I could have rejected, but this is within the range, right? It is within that range of 1.701. Then I cannot reject the null hypothesis because whatever data I have got sample data, it is aligning with the null hypothesis. Generally, I will not say that I will accepting null hypothesis. I can only say with the information available, I cannot reject. Yes, Abhijit.
The टेस्ट स्टैटिस्टिक्स और क्रिटिकल वैल्यू सर कैसे निकला थोड़ा बता सकते हैं? समझ में नहीं आ रहा.
Come again with the information.
सर test statistics and critical value.
Huh. What happened?
फिर वो समझ में
Difference.
नहीं आ रहा कैसे.
Test statistic you just calculated, right? Minus 2.94.
Sir, we are subtracting from which to which?
We're not subtracting anything, right? I found out my test statistics, I found out my critical value. I'm just comparing that. Where does my test statistics lie? I'm no longer doing any calculation. Critical value you found out 1.701 from this table. Is that part clear or not?
Critical. Yes, sir, that's clear.
So you go to your alpha, you go to your degrees of freedom is 28, 1.701, right? So that part is done. So I found out critical value. So there is no more calculation. I found out not, this is not critical value, this is test statistics. So now
Sorry,
I
sir,
have.
I was thinking that was a calculation. That's why I got confused.
Yeah, there is no calculation, right? You are just comparing. Where does my test statistics lie in comparison to critical value? It is above critical value or less than critical value. If it is within critical value, I cannot reject. If it is above
Yes.
critical value, then I will be rejecting the null hypothesis. In this particular case, I cannot reject, right?
Yes.
Let's say the other way around, same data set, but I wanted to find out.
Sir, I have a question, sir.
Yeah, go on.
Sir, if we are like in this situation, we are like not accepting the null hypothesis. Like, sorry, you can't reject
not
the
reject,
null hypothesis.
Yeah.
So, like, is there any situation where we can say that we are accepting the null hypothesis directly?
No.
Or
If that was there, then I would not have created a null hypothesis, right? If I had have only alternate hypothesis, I would have told whether accepted or rejected. So in statistics, there is no way where you can say that, okay, I'm accepting something. You can always say I'm rejecting something. That's why you are creating a null hypothesis. If that method was there where you can go and say that I accept something, only you will create a alternate hypothesis, go and say that, okay, I'm accepting alternate hypothesis. No need of a null hypothesis. We're creating a null hypothesis, a opposite statement, because statistics will work in that way. If I have enough data, I can say that whether I can reject something or not. But no matter how much data I have, I cannot never say that I'm going to accept something.
Yes, sir.
So let's say the other way around. If it says that less than INR 3675, right? So what would have been my alternate hypothesis? Less than null hypothesis would have been same data, right? There is no change, only my research objective is different. Right or wrong? Right? If I have my research objective to show that, okay, it is less than some number, 361975. Same thing I want to prove, less than 361975. Then null hypothesis would have been exactly opposite of that, right? Then what kind of test we would have been conducting? Right, left, or total test?
Left and test.
Left tail test, right? Now what happens? There won't be any change in test statistics because the data set remains same, calculations remain same, still you will get minus 2.94. But only change will happen in critical value. The distribution which will be given to you most of the times, right, only shows the positive value, only shows the right side of the distribution, right? But because it is a symmetrical distribution across zero, zero is the middle point, symmetrically distributed, right? So what happens whenever we are conducting a left tail test, right? I'm looking to the left side of number line, left side of zero, right? Left side of mean. This critical value no longer will be 1.701. In a left tail test, it will become minus 1.701 because minus, I'm looking into the negative side, left side, right? Number line, if it is zero, left side will be negative side. I'm looking into the left side. Now, how to interpret this, right? If I'm comparing, what is my null hypothesis? Null hypothesis says greater than equal to 361975. What does it mean? Whatever sample data I collect, if my null hypothesis is true, and if I'm standardizing the sample data, that means I'm finding out a test statistics. That standardized data will be greater than equal to 1.701 if my null hypothesis is true, minus 1.701. If my null hypothesis is not true or wrong, then it will be less than minus 1.701. Depending upon what is your null hypothesis, my null hypothesis is greater than equal to, right? So if I'm getting a number, getting a standardized data which is greater than equal to this critical value, which is minus 1.701, then my null hypothesis will remain that I cannot reject it. But if it is something beyond that, if it is less than that, right, I can reject that. In this particular case, what will happen?
So we will reject.
We'll accept.
How I am going to accept, right? Is it within the range? So see how the range is changing depending upon, because what I'm telling, my null hypothesis is true, it is greater than equal to. So then what will be my interpretation? If I'm finding a data which is greater than equal to minus 1.701, then null hypothesis should be true. Because my null hypothesis is greater than equal to. So if I'm finding a data which is greater than equal to minus 1.701, null hypothesis would be true. But what did I find? Minus 2.94, which is less than, which is beyond this left side of it, right? In a left tail test, if your data, your observed data is falling left side of critical value, reject it. In a right tail test, if your observed data is falling right side of the critical value, reject it. Yes, Abhijit.
Rejected, yes, yes. Sorry, sir.
Sir, what about an exact match?
If let's say you get minus 1.701.
Yes, yes.
So take the worst case scenario, right? If let's say think about the example what I gave, somebody has a COVID or somebody has not a COVID, right? So type 1 error means false positive, right? Somebody who doesn't have a COVID, you are agreeing to a COVID patient, right? So that time you have to decide whether that is very critical or other way around. If I say that this value is exactly minus 1.701, this test statistics is exactly critical value, right? Whether I should reject it or not, right? So that time rarely it will happen, but it happens, right? Most of the times, 99% of the times, you can say that I cannot reject. You'll go with
Okay,
the say that okay, all hypothesis might be true.
yes, sir, got it.
So same data set, same example, if I just change my objective, right? Your null hypothesis rejection changes, right? So be careful about that. So go step by step, read the question and write down your alternate null, study and variables, dependent. Obviously, in this case, we do not have any use of dependent independent. Next class onwards, there will be a lot of usage on that. You have to understand what is a dependent, what is independent. Accordingly, your kind of calculation will change. Right. So what I've done, I've given you average ATM usage. That is a two-tailed test, right? Let's say bank want to understand whether it is 5 or not. Average ATM usage, right? Monthly in India, whether it is 5 or not, right? I have how many? I think 15 data points. Sample size is 15. Carry out this exercise. Next class we'll spend 10-15 minutes on this. Then we'll jump into two sample t-test, right? So this is the basis of one sample t-test, right tail, left tail. Two-tail t-test carry out on your own. Still any doubt, we'll discuss that in the next class, right? Let me just show you how to use this confidence interval, right? Recently, a lot of elections are happening, lot of exit polls. How generally they conduct these exit polls? They go to different constituencies, different states, different regions. They get that information. It is not that they're going to all the 3 crores or 5 crores voters. So they go to, let's say, 3,000 or 5,000 voters. From each of them, they get that information that what they think about how many parties, how many seats a party will win, right? Let's say one TV company, this media company has gone to 20 locations and they have collected about a party, let's say BJP, Congress, or any BJD, any party, how much seats that party is going to win. In one location, they said that 49, other location 125, some other location 45, like that. They have collected this data. So it is not a case of hypothesis testing, right? Because they are in the channel, they have to show what is the range estimation, right? How much seats that party is going to win, right? So they have to provide a range. Here they don't want to prove whether they'll win greater than 100 or less than 80 or not equal to 80. So that is a different scenario of hypothesis testing. If they just want to show whether they will win greater than 85 seats, then it would have been hypothesis testing. In this particular case, what exactly we are doing? We are trying to find the range, find the confidence interval on which you have 95% confidence that this party is going to win this many seats, right? And that's why if you see a lot of exit polls will show different results. How correctly they have collected data, how many data points they have collected, that will impact their like whatever range they're saying. Generally, this will not be this small, 5,000 or 10,000 data points they collect. But just to show you, I have, let's say I have 20 data points, right? So how to calculate the range this party is going to win, right? First, calculate your sample average. Average is nothing but average formula. So this is your 81.4, right? Now this is something known as margin of error, which provides a range to your sample mean, right? Which provides confidence interval. Remember what we discussed. That provides a range. If I had collected the data about the population mean will definitely fall within this range, right? So I'm trying to find out that range. So sample average, this is X bar I calculated. Critical T value, right? So as you know that critical value, we need two information. One is alpha, that is given as 0.05. Next is degrees of freedom. What will be my degrees of freedom in this particular case? How many data points I have? I have 20 data points. Sample size is 20, minus 1 is 19, right? So if I go to this table, find out 5% alpha is 5%, 19, then 1.729, right? My critical value is 1.729 or 1.73, let's say. So I found out right now how many values. X bar I found out 81.4, critical value I found out 1.73. Next is the standard error. Standard error formula is same thing, standard deviation divided by square root of n, right? Divided by square root of sample size. So first I have to find out my sample standard deviation. Sample standard deviation is that formula STDEV dot S, standard deviation dot S. Select the data points. So that gives you idea about what is your sample standard deviation. Then standard error will be sample standard deviation divided by square root of sample size. I have 20 data points, 10.33, 10.34. Okay. So standard error is 10.34. My critical value is 1.73. So if I multiply standard error with my critical value, that gives a margin of error. So what does this margin of error means? This gives a range, plus minus range to your sample data, right? So that came as 17.89. Okay. So now I can calculate the range within which the population mean. If for that party, if I've collected data correctly of these 20 locations, right? Now with 95% confidence, I can say that upper limit, the highest number of seats the party is going to win will be close to this mean plus margin of error. That means close to 100. Then lower limit will be whatever the mean I have got, 81.4 minus 17.9, 63.5, 64. So now I can go to the TV channel and say that I have conducted this exit poll with 20 locations. With 95% confidence, I can say that I can answer this question. Average number of seats party will win. The average number of seats the party will win will be between 64 to 100. Right? If your sample data was little bit more, right? This n value was little bit more, then your error, the range will come down. Think about this way. If this n was, let's say, right now how many? 20, right? Let's say rather than 20, I have square root of, I have collected data from 1000, 10,000, right? Then what will happen? Now see how your range is changing. 80.6 means 81 to 83. So you are giving a very accurate, very detailed. You are telling, yes, now my confidence level increases 81 to 83. But because I have collected only 20 data points, right? My range is little high, right? So that's how your sample size impacts your the confidence interval or the margin of error. If my sample size is bigger, my margin of error will be less. If my sample size is less, here if you see it is only 20, right? My standard error is around 10.34. Around how much? 12% of my mean itself. That means I'm expecting 12 to 15% error in the data, whatever I have collected. That's how it is giving a very big range. So it can be anything between 64 to 100. But if I've collected the same information, same mean and same thing, if I'm getting from 10,000 locations, 10,000 respondents, 10,000 voters, then my range would have been smaller, right? That's how your sample size impacts your margin of error or standard error. Is this part clear or any doubt? And any question, any doubt on this?
Sir,
Yeah.
sir, my standard error is coming is 10.60. Somewhat different. Shall be that okay?
So
Or
square root of 20 or 19 you have put?
so 19.
Square root of sample size. What is your sample size?
So 20. Oh, sorry.
Okay. So for the next class, please carry out this exercise on your own so that you know step by step how to approach this problem.
So
Do
can
a
you
mistake.
send this Excel sheet?
Excel files I have already shared, right?
Okay.
Excel file I have already uploaded in the classroom. So please go through that, carry out this exercise. Next class, we'll discuss this for 10-15 minutes. Then we'll discuss the two sample t-test. Right?
Okay, sir.
Yeah.
Thank you, sir.
Chalo, take care. Bye bye.